Welcome to Fire Behavior Foundations. Smoke is Fuel. This module covers the core concepts for effective size-up, search, ventilation, and extinguishment. If you remember one line from this video, let it be, smoke is fuel. The principles discussed here are critical locally. Modern fuel loads mean faster fire growth. We often operate with limited manpower and water, especially outside protected areas. Ventilation changes conditions fast, making these foundations vital for our safety and success. Our training objectives are practical. We aim to explain why smoke is fuel, recognize high-risk smoke conditions, understand ventilation-limited fires, introduce concepts like rollover, flashover, and backdraft, and apply smoke reading to real scenarios. The central idea of this session is that smoke is fuel. More importantly, smoke can ignite violently when oxygen is introduced. Understanding this is key to coordinated firefighting operations. Fire behavior is not just theory. This is what we respond to. Even without visible flame, smoke can be rich in fuel, heat, and toxins. Recognizing and managing this stored energy is crucial. We move from the traditional fire triangle, fuel, heat, and oxygen, to the fire tetrahedron, which adds the chemical chain reaction. Operationally, this means we cool gases, control openings, and stop pyrolysis to interrupt the reaction. Smoke is unburned fuel gases, soot, heat energy, and toxic products like carbon monoxide and hydrogen cyanide. Simply put, smoke equals fuel plus poison plus heat. Always mask up early to protect yourself from these hazards. Fire doesn't burn solid stuff, it burns gases. Heat causes pyrolysis, which is fuel generation. This process produces flammable gases that burn when mixed with oxygen. A simple rule is, if it's smoking, it's producing fuel. Pyrolysis is the breakdown of solids into fuel gases by heat. More heat means more pyrolysis and faster fire growth. Water cools surfaces, which slows down this fuel generation process. The smoke layer is stored energy. Think of it as a fuel cloud. This hot gas layer stores significant energy and fuel. Introducing air to this environment can cause rapid ignition. Fire development follows a simple path: incipient, growth, fully developed, and decay. The danger zone is late growth and early decay. Decay does not mean safe. It often means a buildup of fuel-rich smoke in an oxygen-limited state. In a fuel-limited fire, there is plenty of oxygen, but the fire is limited by available fuel. In a ventilation-limited fire, the space is oxygen-starved, and fuel gases build up. Opening doors or windows in a ventilation-limited fire can cause rapid, dangerous fire growth. We use VVDC, volume, velocity, density, and color for quick smoke reading and size up. Velocity and density often provide the strongest risk cues. Remember the rule: fast smoke equals fast fire. Velocity is the most important indicator. Lazy smoke means lower heat and pressure. Fast or turbulent smoke indicates high heat and high pressure. Pressurized smoke pushing from seams or eaves is a strong warning sign of a dangerous situation. Thick smoke density indicates stored fuel and incomplete combustion. Dark brown or black smoke often signals high heat and fuel-rich conditions. Remember that color alone isn't enough. Always interpret VVDC indicators together for a complete picture. Rollover, or flameover, is the ignition of smoke gases in the upper layer. Indicators include tongues of flame overhead and rising heat. Our action must be to cool the gas layer, stay low, and control any openings. Flashover is the near-simultaneous ignition of combustibles in a compartment. Indicators include rollover, a rapid heat increase, and a dropping neutral plane. Without protection, this condition is unsurvivable. Backdraft is an explosive ignition when oxygen is suddenly introduced into an oxygen-starved, fuel-rich environment. Signs include pulsing smoke, smoke-stained windows, and a pressurized interior. Crucially, door or window openings can trigger it. A key tactical takeaway is to control the door. This limits oxygen intake, reduces flow path hazards, improves survivability spaces, and allows for coordinated ventilation with water application on the fire. Consider this residential scenario. Smoke is pushing from the eaves with no visible flame. What does VVDC indicate? Think about your first 3 actions with short manpower, focusing on controlling the flow path and applying water. Let's review what we've covered. What is pyrolysis? What does VVDC stand for? What does fast smoke indicate? What is the difference between rollover and flashover? And what is the importance of door control? In summary, remember, smoke is fuel, most residential fires are ventilation limited, and you must control openings and cool hot gases. The next video will focus on ventilation and flow path, including local case photos.